Hi everyone. We're going to do section 3.8 today. Section 3.8 is all about inverse functions again and radical functions. So section 3.8, inverses and radicals. So we revisit that whole idea of inverse functions, and then we're going to calculate some of them with that involve radicals. Okay. An inverse of a function, and this is a reminder from back from section 1.6, basically switches x and y coordinates. For example, if I had f of x equals 3x plus 7, and I had f inverse of x is x minus 7 over 3. Those are inverse functions. You can verify that using the methods from 1.6 if you'd like. But if I did x and y coordinates for f of x, 0, 1, and 2, put 0 in. 3 times 0 plus 7 is 7. 3 times 1 plus 7 is 10. 3 times 2 plus 7 is 13. Over here, the x and y flip roles. So this time the x would be 7, 10, and 13. 7 minus 7 is 0 over 3 is 0. 10 minus 7 is 3 over 3 is 1. 13 minus 7 is 6 over 3 is 2. So as you can see, those are inverse functions. That's just a reminder of what they are, okay? Here we go. Let's do an example. If I give you y equals x squared plus 1. So if I were to graph that, I'm going to end up getting a parabola with a vertex of 0, 1, right? It's like the y equals x squared parabola shifted up 1 unit. So it looks like I get, let's see how effectively I can draw this. Apparently not very effectively. So I may have to go half at a time. Oh boy, I missed. Okay, well, just accept that that's a prettier graph that it turned out. Okay, so there's my y equals x squared plus 1 parabola. Now remember that it's rotated around the line y equals x. If I rotate that around the line y equals x, then I'm going to get my inverse function. So my inverse function would look like this, right? Whoops, I want to go back to solid. So my inverse function would look like this. And you're probably, hopefully, this is giving you the heebie-jeebies, and you're like, that's not a function, dude. That fails a vertical line test. You'd be right. Okay, so recall an inverse is the graph of f of x reflected about the line y equals x. All right, so if you look at this green graph here, this is not a function, right? It's not a function. Fails the vertical line test. So as that original function is written, x squared plus 1 does not have an inverse. This has got to do with that whole one-to-one thing that we talked about in 1.6 that we're going to talk about a little bit more in this section. All right, if I gave you this one, y equals x squared plus 1, and I tell you that x has to be bigger than or equal to 0, I have now restricted the domain. The domain was all real numbers, but I'm telling you only use x values bigger than or equal to 0. So now if we look at this one, y equals x squared plus 1 with x bigger than or equal to 0, you get a half a parabola. So half a parabola is certainly 1 to 1 now and has an inverse. So here's my y equals x line. Totally missed in that one. Let's see, y equals x. That's good enough. All right, so it would look like this, wouldn't it? All right, and that one is a function. So with the restricted domain, this function does have an inverse. Okay, so now let's find it. So remember how to find inverses. You have y equals x squared plus 1. We're going to switch x and y. So x equals y squared plus 1. Now we're going to solve for y. So subtract 1. Then I'm going to square root both sides. Usually we have a plus or minus when we square root both sides. This time we're only going to do the plus. If you look at the graph, right? We look at the graph, the inverse function right here where my arrow is tracing along, that inverse function has y is bigger than 0. All right, so I got to have the positive square root. So f inverse of x is the positive square root of x minus 1. All righty, so just for a reminder, let's write down when a function has an inverse. So a function has an inverse if it is 1 to 1. All right. So 1 to 1 means for every x, there's exactly one y. And for every y, there's exactly one x. All right. What this means for a 1 to 1 function is that it must pass the horizontal line test. Okay, so a 1 to 1 function passes the horizontal line test. In other words, the graph will never pass through the function more than once if it's 1 to 1, a horizontal line. Alrighty. Okay, just have a couple more examples and we'll be done with 3.8. I gotta open up a new page. Okay, so let's do this example. For what domain is f of x equals x plus 3 squared 1 to 1 and non-decreasing? So the first thing we should do is we should graph this bad boy and see what happens. Here we go. So y equals x plus 3 squared is going to be the basic parabola, y equals x squared, shifted 3 units to the left, right? Because it's x plus 3. So if I shift this sucker 3 units to the left, I'll be right here, right? So let's see if I can graph it effectively. So there's the left half of the parabola. Here is the right half, and there's the left half. All right. So that one's definitely not 1 to 1. So it would not have an inverse the way it stands. But we could restrict the domain here so that it does have an inverse function. So it is 1 to 1. So they want us to restrict the domain so that it's non-decreasing. So it's decreasing on this interval here, so that's not the one we want. We want it to be non-decreasing, so start here and go up like that. It's non-decreasing on that interval right there. So it's non-decreasing on the interval from -3 to infinity. Okay, so let's write that down. Non-decreasing on the interval -3 to infinity. So if I restrict my domain to that, then I can find the inverse function. Let's do it. What is f inverse of x? So y equals x plus 3 squared. Switch x and y. So x equals y plus 3 squared. Square root both sides. And I get that. Now subtract 3 from both sides. And it looks like y has got to be positive. Y plus 3's got to be a positive square root of x because it's above the x-axis. So there we have it. So f inverse of x equals radical x minus 3. So that's going to be the square root graph shifted down 3 units, right? So you'd actually end up with that right there. So compare the green graph to that graph right there, and it's definitely reflected around that y equals x line. All right, everyone? All right, what if we have a cube root? Would we still be able to figure out the inverse function if I have a cube root? I think the answer is yes. So find f inverse of x if f of x equals 3 times the cube root of x minus 7. Same steps, right? Cube roots are always 1 to 1, right? Cube roots, x cubed, that's going to be 1 to 1. So we don't have to worry about restricting the domain for those. So here we go, we got 3 cube root x minus 7, that's y, switch x and y. Same exact process in all of these. And then solve for y, right? Solve for y. So I'm going to add 7 to both sides. So I get 3 cube root y equals x plus 7. And then I'm going to divide both sides by 3. So I got x plus 7 over 3 equals the cube root of y. Then I'm going to cube both sides. So x plus 7 over 3 raised to the third power. If I raise cube root of y to the third power, I just get y. So then f inverse of x equals x plus 7 over 3 cubed. Okay, that was a fun one. One more. So let's do one that's a rational function. Now I'm going to find the inverse function to a rational function. We're assuming it's 1 to 1, so I don't have to worry about checking that. All right, so find f inverse of x for f of x equals 7x over x plus 3. All righty, first step, y in for f of x. Second step, switch x and y. Third step, solve for y. Well, this one's got a fraction. The easiest way to clear fractions, if you can, is to cross multiply. So if I cross multiply here, x times y plus 3 is going to be xy plus 3x. I'll distribute, and then 1 times 7y is 7y. Now I'm trying to get y by itself, so I should get all the stuff with y's on the same side. So let's subtract 7y, and then get all the stuff without the y's on the other side, so I'm going to subtract 3x. Now since I'm trying to solve for y, I'm going to factor it out. So factor out a y, I have x minus 7 equals negative 3x. Last step before putting the f negative 1 in, divide both sides by x minus 7. Y is replaced by f inverse of x in the final step. So I get that right there. Okay, everyone? So that is section 3.8. We're off to chapter 4 in the next lesson. Chapter 4 is like the signature chapter of Math 111Z. It's all about exponential and logarithmic functions. It's great fun. Can't wait to see you there. Okay, bye.